Hey guys, today we are going to look at this problem. So its rating is 2300, so it's quite an advanced problem. So let's begin. As always, we are going to start from the example here. So there is two numbers at the beginning. So the first number is the number of hooks, right? Now we have 9 hooks, right? And the second number is the number of operations. The following lines are the operations. We have 11 of them. So if the operation is a number bigger than 0, then it's the identity number of a man. So this man will put a code on the hook, right? So for example, if man 1 comes here, then he will put a code in the center of the segment, right? Here is the segment, and where is the center here? Let's see. 1, 2, 3, 4, 5. 5 is the center for 9 hooks, right? So number 1 puts his code here, and here comes number 2, and number 2 will choose the longest segment. So the longest segment is this one, right? It has 1, 2, 3, 4, 4 hooks. And another segment is here, 1, 2, 3, 4, also has 4 hooks. So we choose the one on the right, right? So we choose this segment and choose the center hook. So there is 2 hooks at the center, these 2, right? So we, as always, choose the one on the right. So choose this one. So number 2 puts his code on this hook, right? And here comes the other kind of operation, right? See, sorry. So this kind of operation starts from 0. It means that it followed by 2 numbers, left and right. So this kind of operation is to query how many hooks has code on it between these 2 numbers. So 1, 2, 3, 4, 5. We count from this guy to this guy, right? 5 to 8. So we have 2 codes here, right? So we output 2. And then we move on. So number 1 moves out and he takes out the code. So we remove this guy, right? And then number 1 comes again. So he again chooses the longest segment in the graph. So it apparently is this one, right? This one is the longest. So we choose the center hook of this segment. So center is here, right? And we put number 1's code here. Then comes number 3. So there are 3 segments. This one, and this one. 3 segments, right? And we choose the longest segment, these 2, and we choose the one on the right. So it's this one. And we choose the center position of this segment, which is this one, right? We put number 3 here. And then we run a range query. So 3 to 8. 3 to 8. We have 3 codes, so we output 3 here. And then we move on. We have number 9 coming. So we choose the longest segment here and put number 9 at the center. And we query number 6 to 9. So 6 to 9. We have 2 codes, right? So we output 2. Then comes number 6. And there are few segments here. All of them, the length is 1, right? So we choose 1 on the right and put 6 here. And we run query 1 to 9, right? We have 5 codes in total. So we output 5 here, right? So I guess that's all. So how do we solve this problem? So let's see. So we have to have few data structures to support these 4 operations, right? So the first operations is to break the longest segment into 2, right? So you will have several segments in the graph, and you need to choose the longest one, right? If there are multiple longest ones, we need to choose one on the right, right? So choose the longest segment is the first operation. So the second operation we need to support is to merge 2 segments. What does it mean? So if we take out a code, let's say there is someone put a code here, and there are 2 segments connected to this position, to his left and to his right, right? And this guy moves out of the building and he takes out the code. So these 3 parts need to merge to a single segment, right? So in short, we need to be able to merge 2 segments here. That if we count the one hook that is emptied just now, then we need to merge 1 hook and 2 segments, right? So that is the second operation we need to support. And the third one is to update one hook's state, right? So we have several hooks here, and some of the hooks has close on it. So we need to update the hook's state. So if we put a code onto a hook, we need to be able to update that hook's state, right? So we have 2 states for each hook. If it is 0, then this hook doesn't have any close on it. If it is 1, then it has a code on it, right? We need to update one hook's state. And we need to be able to query hook's states, right? And it's a range query, right? So when we are given 2 numbers, left and right, we need to be able to find how many codes are in this range, right? So this is the last operation we need to be able to support. So how do we make some data structures to support all of these operations? So here we go. So for the first operation is to find the longest segment, right? So how do we do it? So we will have a binary search tree, right? And the binary search tree's key is the nth and the left position. So if we have several segments here, they will be sorted, right? We can easily get the longest segment from all those segments. And we have two keys for the binary search tree. So the first key is the nth, right? So we can get the longest one. And the second keyword is left position. So if we have several longest segments, we will choose the one at the rightmost position, right? Which means the left position of that segment is the greatest, right? So the binary search tree can enable us to find the longest segment in log n time, right? So the time complexity of a binary search tree is log n, so it's trivial. And the second operation, we need to break the longest segment into two, because if we put a code at the center of this segment, we need to break this segment into two segments, into the left segment and the right segment, right? And how do we break the segment into two? We just need to remove the longest segment from the binary search tree, and then we insert two separate segments, right? So that's how we do it. So let's ignore this statement for now, right? So this segment should be here, right? How do we merge two segments? So let's take a look at how do we merge two segments. So let's say we have two segments here, right? And there is a code between these two segments, right? And someone comes and take out the code. This code is removed, right? Then these two segments and this empty hook will merged into one single segment. So how do we do that? So first, we need to be able to find these two segments, right? So we will have a binary search tree to find these two segments. So this binary search tree's key is the left position, right? So this position and this position. So if we query this empty hook's position, we can get this one, right? Let's say we run a lower bound function. Then we can get this guy, right? And we can run another previous node of this segment. Then we can get this segment, right? In this way, we can get these two segments, right? And then we can remove these two segments from the binary search trees. And then we insert a new one, right? That's how we merge two segments into one segment, right? So let's move on. How do we update one hook state? So we will run a segment tree here, right? So we have multiple hooks, and if we put a code on this hook, we will update the segment tree, right? Update it into 1. And if someone take out a hook and take out a code, then we will update this hook to 0, right? And how do we support a range query? Also segment tree. So the segment tree is built for range query, right? We can easily calculate the sum in this range, right? We just need to get the sum between this between left and the right position, right? So I guess that's all. That's all. So we got 3 data structures. The first one is a segment tree to support these 2 operations, right? And then we got 2 binary search trees, right? One binary search tree's key is these 2, length and left position. One of the binary search tree's key is just the left position. So the binary search tree store all the segments, right? So each segment will be appear in both of these segment trees, but these 2 segment trees so will have a different keyword, so it can fulfill their different objectives, right? So I guess that's it. So let's move on to the code here, right? So this part is where we implement the segment tree, right? So this guy is to update one node in the segment tree. Let's say if we want to update position 2 and +1 in this position. So the position here is 2 and the value here is 1, right? And this is the start point. The initial start point of it is 1, right? And the initial end point of the segment tree is infinite. Infinite here is 10 to the power of 9, right? And the p is the pointer to the current node of the segment tree, right? And here is the implementation of the update operation of segment tree. So we won't go into the details here because segment trees implementation is another topic, right? And here is the query of the segment tree, right? We also won't get into the detail of it. And let's move on. So here is the initialization part, right? So initially, left length is one of the binary search tree, right? Its keyword, first keyword is left, the left position of the segment. And the second keyword is length, the length of the segment, right? And initially, there is one segment here, right? And its left position is 1, and its total length is n. So it's the input here, right? And also, another binary search tree is then left, right? So its first keyword is length, and its second keyword is left, right? And its initial state is also one segment, right? Its length is n and the left point is 1. Then we will read the operation here. If t equals to 0, then it means we will run a query, right? We read in the left point and the right point and run a query on the segment tree here, right? So we can get this few operations done, right? And let's move on. So how do we, let's say 1 second. So here is the part where we put on a code on a hook, right? So this guy is in T, means is this, is this worker the first time here? And if the value of it is bigger than 0, it means this guy already, this T already put a code at this position, right? And if it is equal to 0, then it means this guy never been here and he doesn't have a code here, right? So if it is 0, then he is a new guy and he wants to put a code here. So where do we put the code? So first, we find out the longest segment, right? This guy is to find the longest segment. And then we remove the longest segment, right? And then we break the longest segment into 2 segments, right? Here is the part where we calculate the new left segment's length, right? So here is the longest segment, and here is how we break it into 2 segments. And this guy is the length of the left segment, right? And we put the code, put T's code at this place, which is the left point here, plus the new left length here, right? So in this way, we get the position of the code, right? And then we update the segment tree because we put a code here. So we need to change the state of this hook into 1, right? Here is where we update the segment tree. Then we insert the right segment into both of the binary search trees, right? So here is how we deal with a new person put on a code, right? So let's move on. And how do we remove a code, right? How do we remove a code? So first, we already know where is the code, right? And we need to update the segment tree so that this code is no longer there, right? So we -1 at that position. Then we find the we already found the code and remove it, and then we find the right the segment to the right of this code, right? And if this segment is right next to this code, right? And if this segment, left segment, is right next to this code, we will merge these 2 guys, right? So this part is to merge the segment to the right, to the left of the code, right? So that we can get a new length, right? This part is the new length, right? And then we will erase, this part is where we erase the left segment, right? And then we will check the segment to the right of the code. So if it exists, we will merge them, right? And we will erase the segment to the right. And in the end, we will insert the new segments, right, into the two binary search trees. So I guess that's it. Thank you for watching. Bye bye.